So how's it going, everybody? So the first thing I want to say is that you may have noticed that my YouTube channel name has changed. I am changing my name to my in-game name, which I will give you a test. You can see I changed my Minecraft name to The Wild Drive-Eye. Everything I'm changing from GreatGamer34 to The Wild Drive-Eye. I don't want a username with numbers in it. I think that's pretty self-explanatory. Now anyway, moving on to what I got here today. So right now we're on the DataWave beta server. And basically we have the plot of logic from OR that Data built, or arranged, I guess I should say, because each component was made individually. And this here is a component that I made a long time ago and put on the poll. This is a queue, and as you can see, it's a spacing of every 3 blocks for a cell, which is quite poor. Very, very poor. Not only that, I'm using a shift register to keep track of the pointer. So if you wanted to make the queue bigger, you'd have to add a bit to the shift register. Nobody wants to do that. So if you want to go one more deeper, you need to add another section to the shift register. You want to go 2 deeper, you need to add 2 sections to the shift register. So this grows linearly, and that's not fun. And then also look at all this control logic, and it's like missing redstone and stuff. So yeah, this queue, like, look at all the wiring there is. This is not pleasant. So I decided to make something better, and so I made this. And this is a queue, but instead of taking up 3, it takes up 2. But you can see the issue here immediately is, if we want to use a comparator as an AND gate, and if we're powering both sides of it, we need to turn off both this one and this one to get this one to read. If we were, say, over here, we would need to turn off both this one and this one to get this one to read. So I would need some sort of device that would be able to take one location and turn off 2 with it. And so I actually have that device right here. So you can see that right now all these lines are positive. When I select this cell to read, I want this one and this one to turn off, right? Which means I want these 2 to turn off. Which means if I said we selected that, you see how it turns off those 2? So now it will read what's in that first cell right here. Let's do an example. Let's do this guy. So you can see how there it reads the first one, or the second one, and the third one like that. And if we come up, it allows this cell to be read. So this is the system that I used. And so the way this works is it's a buffer. So you keep data moving this way, like this. And then there's a PC, a program counter, that can count upwards and down. Up and down, upwards and downwards, whatever. Anyway, so this can count up and down. And so let's use it, and I'll show you how this works. So let's pop, so right now you can see this says add the value 0. There's zeros coming out of every line of the program counter. So let's push in, I'm going to do, let's do the top bit. Push, and yes, these are technically NQ and DQ. So the Q is at position 0, now it's at position 1, and we wrote a value into position 1, which is a 1. Or which is, sorry, is 128. Let's do 64. And push. And you'll see that it stays on 128, because the first value in the queue is still 128. The second value in the queue is 64. So the way the queue works is it's first in, first out. So the first one in was 128, so the first one out is going to be 128. So we could just keep pushing in values like this. And you'll see that, like, when I actually push it in, like, for a split second, it goes down 1, and then it goes back. That's because it's updating the cell, and it's a little unsynced right now because of this repeater. Okay. Let's push a few more values. And so the other thing with my other queue over there, this guy, is if you wanted to expand it, you had to expand that shift register. This one doesn't have a shift register. So there's no expanding that. It's just making the program counter enough bits to do all the addressing you want. So I have 6 bits of addressing here, but I'm only using 4 bits for this amount of. So that means this could be 4 times bigger. No, this could be some crazy amount of size bigger still, and still be able to fit all the, or still have 6 bits of addressing. And this program counter works up to 8 bits, right? So you can have like a 250. Yeah, you can have a 255 deep queue if you wanted. If you needed something that big. 255 byte deep. So anyway, now I've written in a bunch of values. Let's pop them out. So it should go this one, that 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 one, like that. The only delay on the pop is waiting for the button to depress. And you can just keep popping them out. So it was first in, first in, first out. That's a queue, it's FIFO. Now we pop again. Now we're at position 0. So now let's do it again, and let's pay attention to this PC and watch how this happens. Okay, so let's put in a value like we did. And we see that the PC is at 0. If we see what the push line does, the push line updates all these cells. So what it does is it takes whatever it takes the value that's that's here and writes it to this cell, and takes the value that's here and writes it to this cell, and takes the value that's here and writes it to this cell. So it just moves everything down 1. That's what that line does right there. And obviously, yeah, I need to put a repeater here if I plan on using like more than like the first 8 bits, but I think we only pushed 8 deep anyway, and it worked. And the same is here if true, if I wanted a repeater, and then that would make it synced across the whole system anyway. But okay, anyway. So let's push that top one. So we click the value, and we see that that value is stored in this memory cell. Then we'll do this guy, and the queue was at position 0, and it's now at position 1. So when you click the push button, it increments the queue, or increments the program counter. So now the program counter is addressing this line here, and this line is saying read these 2 here. So it's reading these 2 like this, and then giving this output here. Okay. So now we're going to push a 2, and what you're going to see what happens is this bit here is going to move to here, and we're going to push in a 64. So we have a 128. The 128 is going to move here, and the 64 is then going to be in this cell here. So when I clock this, and then this should stay up here. Yes. And then you can see here that we have the 128 and the 64. And now the queue is at position 2. And the reason it's at position 2 is because the first bit that we entered, which was 127, or 128, sorry, is at position 2. And we want to continue to read the first bit. And that's the system. That's the queue. The other queue worked on the same system, just instead of using an address to keep track of, where it is, it used a shift register that either pushed or like moved forward 1 or moved back 1. But this is much more convenient because you can just keep using program counters and chain this to be as large as you want, and literally just stack this. The design of the cell is quite simple. The memory cell at the flip-flop, the read, it comes through a repeater, comes to this bus, and then you need to stagger like this so that you can fit, these lines through right here. And then the stagger's kind of ugly. I kind of like it. It gives it some character. But yeah, the other thing here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this reaches here. It's nice because you don't need an extra one. It should have been 15, 16 to then come to here to power onto that, right? You don't need that because this one here powers the one above and the one below. So another nice thing about this design is easier on signal strength. yeah, it just like worked out nice. And I guess I could do a full tutorial, but like, if you guys are actually watching this right now and look at this, like I'll hold still right here. It's basically just stack the cell, take one of these two, it's 2 by like whatever size, take it, stack it however many high you want, and that'll be your byte size or your word size. So I did 8 bits, so my word size is 8 bits, aka a byte. And then all you need is my up-down counter that you can find in one of my previous tutorials, and then a decoder, and then this unit I haven't featured anywhere. So basically the way this works is the signal can come in here, it comes in through this comparator that's on subtract mode and then comes through, and then it also comes through a NOT gate through here to another comparator. And so the way this works is, if this one is on, or I guess I should say if this one is off, it's going to force this one to be off too. But if this one was off, it's going to force this one to be off too. So it's a unique way of like forcing the off. So I'll just keep scrolling like this so you guys can see how it works if you want to build one yourself. And then yeah, the timings, these repeaters are on 2 ticks, like this. Just a torch into a repeater. I guess you don't technically need that. You could do this line differently and better, I guess. Depends on what you mean by better. If you move those torches underneath here, and then you line them all up like that, and then that could be your line there. Either way, it doesn't really matter. And then this is a monostable. It's on 4 ticks, and that's 1 tick, so that makes a 3-tick pulse. So that 3-tick pulse is open long enough just for that to move over. I tried doing it with a 2-tick pulse, but this thing just did not want to work right. It was being very weird. So, but on 3 ticks it works. And so the push, like I said before, it just updates those cells and then comes down here and increments the program counter. And so the increment line is just the clock line on the program counter. But the decrement line, or the pop, is just decrement. And then the decrement is, the way you get that to work is first you have to be telling it to go down, and then on the same, like a little bit later, like 2 ticks later, you tell it the clock. So if you watch this, it does this first one and then down there, and that's subtracted 1. So I could press the button again, and now you'll see it go to 0, like that. Yeah, and yeah, that's about it. I hope you guys enjoy. If you guys make it yourself, let me see what happens. Tell me what you'd use something like this for in the comments. And yeah, have a great day.